Hello everyone. In this tutorial, we will add vehicle AI to multiple vehicles by moving the logic to vehicle AI component. And we will improve the target speed by calculate the curvature of the spline. Go to traffic. BP vehicle AI. We continue from the last project. So create a new component, actor component. Name this to vehicle AI component. Open this. We can load the editor layout, default layout. Close all of this function. In this vehicle AI component, add variable motion trajectory component. Motion trajectory component. Object reference. Box collision. Box collision. Vehicle movement component. Chaos vehicle movement component. And this inside this component. So we need to copy the variable from BP vehicle AI. The speed. We can select this, all of this. So we need to copy it one by one. Default max speed, min speed, max speed, target speed, and change this category to speed control. Move this to speed control. And like this variable. Copy this debug control. Debug brake. Debug grid. Debug new spline. Debug line trace. This debug pattern. This name is debug control. Change category to debug control. Then move this to debug control. Grid control. Apply. Grid width. grid gap. And this category grid control. Move to this grid control. Obstacle. Copy this. Avoiding obstacle. Grid center location. Obstacle location grid. Grid. Start index. Start location. Target index. Target location. Add location. Stop and wait. Floor height. And name this category to obstacle. Move all this to this category. Steering. Copy. Offset tangent location. Forward. Highest input key. Freeze actor location. And this category is steering. You can select it here in steering. Okay, turn. And change this category to K-turn. And this overlap with this. Overlap back. Overlap right. Overlap left. Category is overlap. Move to target. Copy. Line actor. Add to final target. Final target location. Arrive at final target. Recall mode. Layer variable. Recall mode. Controller rotation. And this name is move to target. Move to target. Select this category. Move to target. And the last one is road network. And close this category. Next, we will copy all these events first. So copy this, analyze and map obstacle. Copy this event, generate path spline, and this go to target location and update target location. And this event take and begin play, we already have it. Next, we need to copy the function. This find nearest spline. Copy this. Calculate steering input. Calculate brake input. Via trace grid, we have some function reference that could not be resolved. Get grid center location, draw debug sphere with point. So we need to copy this function first before we copy that function. Cancel. Copy get grid center location and draw debug sphere with points, and then copy speed trace grid. Find nearest location. Find base target location. Grid index to point. Grid point to location. Found new spline. Check target arrival. This one we need to copy this reset default spline first. And is final target near last spline point. Copy this reset default spline and find is final target near last spline point. Then back to check target arrival. Copy stop vehicle speed control, set spline point, detect obstacle, point to grid index array. This initialize vehicle variable. We need to copy get vehicle floor height first. And copy initialize move to target. Then copy initialize vehicle variables. Okay, this line trace obstacle right. We address K-turn location. We address K-turn. Find next line location. We have a lot of functions. We can close this tab. This perform K-turn. We need to copy this turn vehicle with target location first. And perform K-turn. And this turn vehicle with target location. And then perform K-turn. It means this has completed direction change. Find copy this has completed direction change. Copy this 2 times, so delete this. And then perform K-turn. Next is perform reverse alignment. Adjust path away from obstacle. Refine path with obstacle avoidance. Add path location to target. Reset spline on distance. Adjust final target location. And is spline too short? Can reach grid edge. Should use road actor. And the last one is create road network path. And we close all of this tab. And let's compile this. We will have some error with this vehicle actor, so we not yet think about this. We need to copy this macros. Copy this reset pathfinding. And we lost some note here is delay. For delay for this duration. Copy this line trace obstacle. copy this can perform K-turn first. And we lost this delay here. If it's true, we call delay for 0.2 seconds. And can perform high K-turn. Copy this can perform turn maneuver. We need to add macro to this. Connect. Call can perform K-turn here. And this, when it is true, can perform high K-turn. Next, copy final target arrival. Next, we need vehicle actor. Add another variable is vehicle actor. Name this to actor. This object type is actor. And let's compile. We can see that we have a lot of error, so we need to fix this. Click on the error. Because before we use BP we call AI and now we use actor. Delete this. This process pound that we call actor and call indicator and connect to this in pound. Let's compile. Now we lost some of the error. Yet actor location. This is the actor component, so we don't have the actor, so connect this vehicle actor. Just continue add this vehicle actor to each error. Let's compile this. And we can close all of these functions. And compile this. And we can close all of these functions. Let's compile. Now we don't have any error. This player vehicle, we need to change this from BP vehicle to actor. And change variable type. We compile. After we set this player variable, we need to process by using instigator connect to this pound. Can close this. Now let's copy all this event, this function that we use in the event begin play. Copy and paste here. This event tick. This event tick. Move it further. And we lost the macro when we copy. We need to call it again. This one is final target arrival and line trace obstacle. connect it here. This. Here is can perform turnover. And when this fall, we call reset pathfinding. Duration is 1. And we call this reset pathfinding when we stop vehicle. And check the duration is 4. Move this down. Next, copy this. And delete this comment. Do 1 and reset. Copy this. Generate path spline. We copy this. Connect this target location to this target location. And now we compile. And we got some error. So we need to fix this error. This first one, we need the same as before, we call actor. This we call actor. Get we call actor. Let's compile. And we successfully compiled. Now we don't have any error. Move this a little bit up. Next, we need to set the variable, this motion trajectory, this we call component, movement component, bar collision. So in this begin play, let's create a sequence. And disconnect this first. First, we get owner. The owner of this component is vehicle actor. So set to this. Then get this vehicle actor, get component by class, vehicle movement component, and check if it is valid. Is valid. That vehicle movement component if it is valid. And if it is not valid, we need to call print string. Change this color to red. Or 1, print 0, blue 0. And we print string. We call movement component isn't valid. We can copy this and get component by class is box collision or box component. And then we set to this box collision. Check if it's valid. Set to this. And this print string. If it is not valid, box collision isn't valid. Next, we get component from vehicle actor is motion trajectory component. And call is valid. That motion trajectory component. Get owner. We can add component when it is not valid. Add component by class. Name this motion trajectory component. And then we set to the variable motion trajectory component. And then we set this controller rotation. You can compile and save this and go to motion trajectory component. This vehicle owner, we use BP vehicle AI, change this to actor. Change variable type. First, we get owner and we don't need to cast to BP vehicle AI. We just set it directly to vehicle owner. We compile and we have some error here. Get vehicle We can add another variable. Name this to vehicle movement component. This type is vehicle movement component. Click reference. Vehicle movement component. Object reference. Get vehicle owner and get component by class. This vehicle movement component. Check if it's valid. And if it's valid, set it to this vehicle movement component. And if it is not valid, print string change to red color. Vehicle movement component isn't valid. Compile. Next, we need to get this vehicle movement component and connect to this get forward speed. Compile. And we don't have this any error in this motion trajectory component. Let's save this. For this trace obstacle, we can move this back a little bit. Get vehicle movement component. Get forward speed. Absolute greater than 10. Then we create a branch. We trace the obstacle when this true. Compile, save, close this motion trajectory. Now we can delete this. We call AI in this scene. Next, we can add this vehicle AI component to our vehicle. Go to city sample, vehicle, blueprint. This is the parent blueprint is BP vehicle. So we add this box collision. For your own vehicle, you can use this method too. When you have this vehicle movement component in your blueprint. So add box collision. And another one is vehicle AI component. To viewport. And this box extend, we change this 220, 100, and Z is 50. The height is 80 minus 20. We adjust it to the shape, the size of this vehicle. Can compile and go to the child vehicle, vehicle 1 van. We need to change the shape of the box collision. This is too long, so we shorten it a little bit. Vehicle 2. And we can move it forward. Vehicle 3 is look correct. Vehicle 4, and we can close it. This is correct. Vehicle 5, vehicle 6. We change this until vehicle 13, all of the vehicle. This van, vehicle 9. This bus. And this truck. And this have the correct shape. So we can close all of these vehicle. And save all. and open this vehicle AI component again. Go to this BP flight path. We want to get all the vehicle from the scene. To control that vehicle, we need to change this vehicle AI. Name is vehicles and change this to actor. Change variable type. Change to array. And when we compile, we get some error. We get this error because we get actor of class. So we need to delete this. And this begin play, we disconnect from this. This called when event process. In begin play, we get all actors of class. The class actor is actor because we want to use general class. Because for your own vehicle, you can change to add the name of the actor blueprint. So call for each loop. Get component of class by class. The component is vehicle AI component. So check if there is vehicle AI component in your actor is valid. If it is valid, we add to vehicles array. And when we complete, get vehicle, get a copy, get variable. This variable is current vehicle integer and single. Get current vehicle, and this current vehicle is 0. We get component by class. We call AI component. And we take this vehicle is valid. Add another variable is vehicle AI component. Vehicle AI component object reference is valid. Set to this. And it's not valid, we print string. Change to red color. Okay. No vehicle AI component available. And move down this area, we set the vehicle mode. So we don't need to set this vehicle mode. And this go to target. We need to get vehicle AI component called is valid. If it is valid, go to target location. Go to target location, this hit location. And it's not valid, print string. Change this color to red. No vehicle AI component available. And this why here we don't need this, we can delete this. And next we can add tab key. When we press tab, we want to switch to other vehicle to control that vehicle. So get vehicles, get length less or equal to 0, range. If this true, we copy this print string no vehicle available. Get current vehicle, add with 1 for the next vehicle, and check if it less than vehicles array length. We add a branch. When this false, and we set this current vehicle when it less than this length. And if it false, we set it to 0. Next we get vehicles, get a copy with this current location, current vehicle, and get component by class. Vehicle AI component called is valid. Set this vehicle AI component and get current vehicle. We print string this. And vehicle space and this number of vehicle. Next, we draw the backsphere to highlight that vehicle. And we get the location of this vehicle actor. Get actor location to this center. And we can change this color to green. Radius is 300. Duration is 0.5. Path. And we don't have any error. Go to level blueprint. Open level blueprint. Now we don't need this vehicle AI and this tab. We don't need to change this mode, vehicle mode. So delete this. And this Shift3, don't need this. Delete this variable. Delete this found replacement car function. Go to process vehicle. And close this. Let's go to motion trajectory component and draw the back this. Check if this is working or not. And drag this vehicle 3 and drag another vehicle 13. Let's play. Now click on one location. So we have this vehicle 13 here. Near this road. And when we press tab, we can switch to this vehicle and control this vehicle. And now it is working also with this motion trajectory. So disable this. Draw the back type. Go to vehicle AI component and go to this final target arrival. Get arrive at final target. Create a branch. If this is true, we stop the vehicle. And we want to destroy the spline when we arrive at the final target. Create the sequence. Get spline actor. Check is valid. Get default spline is valid. And we can disconnect this speed near arrive speed and delete this. Because we will use the curvature of the spline to control the target speed, we don't need this. It's valid. We destroy the actor if it is valid. Go to this stop vehicle and this speed call in range. Min is -1, max is 1. We add a branch. When this fall, we stop this. And if it's true, we get vehicle movement component. Set throttle. Input is 0. Set brake. Input is 0. Compile. Play this. And set this target location. And when we arrive at this final target, we destroy this spline. Now, because our vehicle have different shape, so we need to adjust the line trace. This line trace. This multiply. Let's get box collision. Get box extend. Break this with the y multiply with 0.8 and multiply with this. Convert this to float. We copy this calculation down here. Get x multiply with -1. And this forward trace. Connect to this. And connect to this. If this forward trace is true. Then multiply with 1.5. And we copy this. Move here. And delete this. Paste it here. Multiply with -1. The same with this. We copy this. Need to multiply. Then this line trace obstacle right. Get box collision. Get box extend. break vector x multiply with 0.85 and we multiply with this forward vector. Then copy this. Y we multiply with -1. Connect to this. Connect to A. This Y. And this multiply with 2. And we copy this. And connect to this. Multiply. And copy this. Multiply with -1. You connect it here. Compile. Let's drag another bus to check if this line trace is correct. And this line trace. Let's set this draw line trace to true. First, we control this vehicle. This correct for the line trace. And this bus. And we have the correct line trace. And we set this debug line trace to false again. Close this. Go to this function reset spline on distance. Reset spline on distance. Reset spline immediately. Reset spline immediately. Open this. And we can delete all of this. Delete this line trace or spear trace by channel. Get actor location. Add bit. This we call actor. Get actor forward vector. Multiply with this float. Convert this to float. Get box collision because we use the box collision size as the scale for our line trace or speed trace. So you need to adjust the box size according to your vehicle. And then connect to start. Get offset engine location. Need to add. And get grid gap. Integer to float and divide by 4. This is the radius. Next we get spline actor. Get spline. Find location closest cover location. Get vehicle actor. Get actor location. Display location. And display coordinate space. Or distance from this closest location to this actor location. Check if it's greater or equal to grid gap. Multiplied by 4. Or Boolean. If one of these conditions is true, we do the reset spline immediately. And before this, we need to get stop and wait. Check if it is false. And we can connect to this reset, analyze and map. We delete this reset default spline. Compile to event graph. We need to adjust this speed control. Vehicle speed control. We need to add new variable is current throttle. This variable is float. Add variable target throttle. Get current throttle. Target throttle. Call f interp2 from this current to this target. And get var data second as the data second. Interp speed is 2.5. Call select float. Get vehicle movement component. Get forward speed. get forward speed mph. Less than, get mean speed. If it is less than mean speed, if it's true, we set this target throttle. And if it's false, we use this interp tool. To this. And we can copy this handbrake fall, delete this, and move it in front here. Set handbrake to fall. And we get this speed, forward speed mph, and we don't need this. Sorry, we don't need this target speed. We will adjust this target speed later. When it is less than target speed, we don't need this brake input. And call set target throttle. If true, we set to 1. If false, we set to 0. So if it's false, we set to -1. And this one, we don't need this target speed. Need to fall. And this target speed, we clamp this, clamp float. W min is 0. Max is get min speed multiply with 3. Because this, when we reverse the vehicle, we don't want the vehicle to move very fast. So we need to clamp the max speed of the target speed. And this set throttle, we set this current throttle. Okay. Next, vehicle movement component. We need to set brake input. Brake to 0. And the other one, brake is 1. Compile. Go to this. This find base target location. We need to use default spline instead of spline actor. Now if we play, if we set the target, the vehicle will not move because we don't have the target speed. So we will calculate the target speed with the curvature of the spline. Go to vehicle movement component. We can save all of these first. And we can move this start location up here to make it look more balanced. And this one, it has similar length, the top and the bottom. This perform K-turn, we can collapse node and name this K-turn and reverse alignment. And create a sequence here before this K-turn and move this take target arrival to this sequence. And we remove this sequence pin. Add another function, name it calculate target speed to curvature. And we go to event graph and set this to calculate target speed to curvature to this sequence. Add the new function. The function name is get point spacing and add some local variable, current speed, and another local variable is local point spacing. Let's compile, and then we add the input of this function, change to float, min spacing, and the one is max spacing. And output, the output name is point spacing, and the default value is 250. Max spacing, the default value is 500. This return node, get vehicle movement component, get forward speed mph, absolute, clamp, float, value, we get max speed to this max. and call set current speed. That is current speed. Get min spacing. Get max spacing. Loop from A to B. Alpha is current speed divided by max speed. Get max speed. And this alpha. Set local point spacing. Then we return local point spacing. Add another function. This function name is get number of sample points. At local variable speed vector float. And another variable is local name points integer. And add input. The input name is min points. Float. Add input. Max points. The for value 5 and 12. Add output name points integer. Then we get vehicle movement component. Get forward speed mph or absolute. Claim this value. Claim float. The max is get max speed. And then divide this by max speed. Copy this max speed. Set speed vector. And we get min points. Get max point. Loop from min to max. The alpha is speed vector. Because we want the vehicle when it moves fast, it have many points project to the future. And if it is slow, it have less points. And around this to integer or set local num points and return this local num points. Next, we add another function. This function name is sample points on spline. And we need local variable point spacing float we call near distance float local sample points vector array sample distance float integer 30 single and local sample point f vector index integer and in this function first we check the spline actor is valid or not. Copy the spline actor and get spline. Get distance along spline. Add location. This coordinate space is first. Copy the spline actor. Get actor location. This location. We clear this local sample points. And call get point spacing 250 to 1000. Set to this point spacing. Then get number of sample points. Min is 6 and max is 12. Add another variable to the global variable is expected point integer. Set this by add this with 1. Next we call for loop with break. From 0 to this sample points. And we set to this index. Get near distance. We call near distance. This index multiply with point spacing we need to convert this to float and use this float multiply and add with this we call near distance. That's sample distance. Check if it's less or equal. Get spline actor. Get spline. And get spline length. If it's less or equal to spline length, we check this. If it's true, we do the pair trace. Is it overlap with any obstacle? So we create another pair trace by channel. And set local sample point. Get spline actor. Get spline. Get location. Add distance along spline. And the distance is sample distance per coordinate space. And set to this local sample point. And to add get index. Check if it's equal to 0. Select vector. Connect this to A. And copy this. Connect to B. But this distance we get the sample distance. Subtract with space point spacing. It's less than 1 index. So it is the start. And this radius get grid gap to float. Divide it by 2. Make 2 radius. And this we set to path overlap. Add another variable. This global variable is path overlap. Boolean. Set path overlap. Collapse this. Collapse node. And name this to path overlap with object. And this is the input. And this is output. And we return this overlap. Name this to overlap to sample points on spline. If it's true, we call this check overlap with object. And if this overlap, we break this loop. And when it falls, we continue, get local sample point, get length equal to 0. Create a branch. If this true, we get local sample points and add with local sample point. And if it falls, we check this. Local sample point, get a reference last index. Distance from last index to local sample point. And check if it's greater than 1. We add a branch. If it's true, we add to this local sample points. And when we complete this loop, we add another variable, actual points, integer, set this actual points when we complete, and get local sample points, length next to actual point, and we return. We need to return this sample points and rename this output to sample points. And now we complete this function sample points on spline. Rename this to from calculate target fit from curvature. And call sample points on spline. We can add local variable is sample points with the array and set these sample points. Call for each loop. Then draw debug sphere to debug it. Set this color to red. And let's play this. Click here. So the location is not correct. Let's check this again. We call this wrong. This is not spline actor. We get v equal actor. Play. You can see now we have the sample point on spline. And we have 1, 2, 3, 4, 5, 6, 7. We have 7 points. If the vehicle move faster, we can get to 12 points. And this spacing, it depends on the speed of the vehicle too. And we can delete this. Draw the backsphere. Compile. Add another function to calculate curvature. Name is calculate curvature. We need 3 points for the calculation. Point 1, vector. Point 2 and point 3. Get point 2. Get point 1. Subtract point 2 with this point 1. And we normalize this. And we add local variable is direction 1. This is single. Set this direction 1. Add another variable is direction 2 and direction 3. Set direction 2. Copy this and set direction 3. Copy this. We get point 3. Subtract with point 2. Point 3. And point 2. Sorry, we don't need direction 3. We only need 2 directions, direction 1 and direction 2. And add another variable is delta tangent. Set this delta tangent. Get direction 2. Subtract with direction 1. And this is delta tangent. And we return this delta tangent length, vector length. And this return value is curvature. Compile and close this. Add another function. This function name is weight average curvature. And add local variable is weight sum load weight total weight. And this input is curvature. This is float and array. Add another input is decay factor. This is single float. Call for each loop of these curvatures and multiply it with weight. Get weight. Add it with some weight sum and set to weight sum. Next we get total weight. Add with weight. And set to total weight. Add weight. Multiply with decay factor. And set to weight. And when this complete, we return. We create a branch and get total weight. Get sum weight sum, divide with total weight. And we get total weight is greater than 0. If it's true, we return this sum weight divided by total weight. And if it false, we return 0. And don't forget to set this weight to 1 when we multiply. This multiply with this curvature. Like this. Next, add another function. Calculate sample points. Curvature. Add input. This is sample points. And vector array. Add local variable is curvatures array and sum single get curvatures and clear this curvature. This sample point we get its length, subtract with 2, call for loop from 0 to this last index, and we get sample points this array. Check if it's valid index. We check 3 points because this 3 point we will calculate the curvature. So this index plus 1 and plus 2. Call n. So we need this 3 point to be valid. Then create a branch. Get sample points. Get reference. Copy this. The first is this index. This index plus 1. And this index plus 2. And this point we calculate curvature. And this to the first point, 10, third. And this result we add to this curvatures array. And when we complete, we call weight average curvature. Get curvatures. And decay factor is 0.8. Get curvatures. And make offload array. Claim this make value. Claim float. Min 0. Make it 0.5. Then add this with this make value. We add this value with the claim. Divide it by 2. Then claim this. Claim float. Min is 0 and make is 0.6. and call return. Add output, curvature, total curvature, load. And this is the total curvature. And this one is the curvature. Close this. Go to calculate target speed from curvature and get sample points. Call the function that we just create. Calculate sample points curvature. And then add variable curvature, float, add variable total curvature. Set this curvature and total curvature. Now we get the curvature from the sample points on the spline. Add another function. Map curvature to target speed. Then add input, curvature, add make curvature. And claim this value. Min is 0 and max is max curvature. And we divide this by max curvature. Subtract 1, subtract with this value. Over by 2. Get max speed. Subtract with min speed. Get min speed. Multiply. Get min speed. Add with this. And return. And we return this result. This is the target speed. And we can go to this curvature, set the default value. Curvature is 0 and this max curvature is 1. Go to this calculate target speed from curvature. get curvature, and we map this curvature to target speed and set this curvature and set target speed. Go to max speed and set this max speed to 100. Now let's try play this. Our vehicle will drive faster than before because we have set the max speed to 100. And the speed is depend on the curvature of the spline. Next, we go to vehicle AI component. Go to event graph. This calculate steering input. We collapse this. Collapse node and name it to set spline direction. We don't need this time offset location, so we can delete this. And connect this to the output. Go back to calculate steering input. And we need to recreate this. This time offset location. We don't need it, then delete this. For this line, check if it's valid. If it is not valid, we reset default spline. And if it's valid, we continue to the sequence. And we can delete all of this. We can get spline, get spline, get distance along spline at location. And this coordinate is world. Get vehicle actor. Get actor location. And use this as the location. Get forward. Then select float. A to 325 and B is 400. Then add this together. Next we get vehicle movement component. Get forward speed mph. Select float. Get motion trajectory component and detect. If we detect the obstacle, we use this speed as W to add with this. And if we don't detect the obstacle, we add with target speed. Get target speed. And multiply with 5. Next we get spline. Get location at distance along spline. Because this is the distance, so we get distance along spline. Next to distance and world coordinate. Now we can set offset tangent location. And set spline direction. And we copy this debug steering. If we want to debug, delete this. Next is this your data. You need to set this. This vehicle actor, get actor location. Find look at rotation to offset tangent location. And we get the data from this actor rotation. If forward, we combine with this value. And next we can delete this. Add another local variable is steering input. Get your data and map brain clamp minus 15, 15, minus 1, and 1. This is the degree of this your data, and we convert to input minus 1 and 1. And we get forward, like float. Multiply with minus 1. Get overlap left. get overlap right or Boolean and Boolean get forward not Boolean and select float. If this true is 0 and if it false, we use this steering input and remove this. And we set this steering input. Next to this steering input, and we return this steering input. And we search for max speed. We need to find this class member, the max speed. We need to remove set max speed because before we use this max speed as the speed of the vehicle, but now we use the target speed for the control the speed of the vehicle. So we don't need to set this. And this set max speed. We can search for this max speed variable again, and we only get max speed. We don't need to set it. Now try play this. We can see that the vehicle speed is really fast, so we need to adjust some variable for the target speed. Now we add another function. Calculate alignment error. We need to use the alignment of the vehicle with the spline to adjust the target speed. Add input. The input is forward vector. Change to vector. Tangent. This tangent is vector too. So call normalize this vector to become unit vector. And we add local variable. This is normalize forward vector. And another variable is normalize tangent. And set this. Get normalize forward dot product with normalize tangent and claim this. lamp float. Min is -1 and max is 1. Add another local variable is cos data. This to float. Set this. And we return. Get this cos data. A cos degree. To return the degree. Next, we add another function. Adjust target speed with sample alignment. And we add input. The first one is vehicle forward vector. Sample points. Array. Curvature by speed. And this one is float. Alignment threshold. And alignment weight. We need to set the default value. Alignment threshold, let's set this to 10. And alignment weight is 0.8. First, we add local variable. Total alignment error. Is valid segment. And we set both of these to 0. Get sample point. Get length. And subtract this with 1. Next, call for loop. From 0 to the last index. Then get this index, add it with 1. Get sample points. Check is valid index. We continue when it is true. We get this sample points, get reference, and use this index, add with 1. Copy and use this index. The next index subtract with the current index. normalize, and set to tangent. Add another local variable is tangent vector. Calculate alignment error. Get vehicle forward speed, forward vector, and this tangent. And set this to alignment error by add another local variable is alignment error float. Get alignment error if it's greater than the alignment threshold. Create a branch. If this true, we get total alignment error. Add with alignment error and set it to total alignment error. Then we get valid segment. Get valid segment. Add with 1. When we complete, we create another sequence. Get total alignment error. Get valid segments. Divide this. Get valid segments greater than 0. Create a branch. And if it's true, we set average alignment error at another local variable is average alignment error. Set to this. And we get average alignment error divided by 45 time float. Min is -1 and max is 1. Call absolute. And we set at another variable is normalize error. Set to normalize error. Get normalize error. Multiply with get alignment wedge. We subtract one, subtract with this, add another local variable is slow down factor. Get slow down factor multiply get curvature by speed claim this, claim float, get mean speed, and get max speed. Add another local, name this to tangent speed, and set this tangent speed. And if this false, we set tangent speed with curvature by speed. And we return get tangent speed. And this output is tangent speed. Now go to calculate, go to calculate get speed from curvature, and we continue by call adjust speed, target speed with sample alignment. Get forward, and select vector, get recall actor, get actor forward vector. This is the forward, and this multiply with -1. This is recall forward vector, and we get sample point. And this is the base speed from target speed. We disconnect this. Sorry, this name is incorrect. This is not tangent speed. We need to change this to target speed. So this is target speed. Alignment threshold is 10 and alignment weight is 0.8 is correct. And we set this to target speed. We can change this to tangent speed. And the return node is target speed. So let's play this. Now our vehicle is better controlled with the speed. It slows down when it needs to turn, but it still overshoot the target location. Can close this function and add function. This function name is adjust target speed based on remaining path. And add input actual point, integer, expected points, and this is speed float. This expected points less or equal to 0. If this true, we return mean speed. Return node get mean speed. This mean speed is 5 miles per hour. Get actual points. Get expected points. Divide the actual point with expected point. Convert this to float. Hour by 1.5. Set slowdown factor at the local variable is slowdown factor. When it falls, we call this. Then get mean speed, get speed, get slowdown factor, and we love this speed. With this alpha and clamp float. Get mean speed, get max speed. And then add another variable, local target speed. And we return this output is target speed. That is local target speed to this target speed. So we slow down if we get the actual points less than these expected points. So to event graph, this calculate adjust target speed based on remaining path. And we connect this. That is target speed. And this is the speed. Get actual points. Get expected points. And we need to return. We want to check that is the curvature is too strong for the vehicle. So get total curvature greater than 1.5 and get vehicle movement component. Get forward speed mph less or equal to 0 to 10 when the vehicle is slowing down. And we return this too strong curvature. Boolean. And go to event graph. When it is too strong, we need to reset pathfinding so we can create another path that is smoother. Compile and save. I copy this road network from this map. Delete this road network. You can create it by yourself for more complex road network by using this road network tool. And we can go to road network tool and click create. We copy all these box, map, this scope. We have all these box. Save all. And this box mesh. That is fine material. And we can move this vehicle here and rotate it 180 degrees. Turn this location and move this pass here. And let's try play this. Now we can set this location, and this is very sharp angle. So our vehicle will spawn another line. And this vehicle reach the correct target. Next, for this refine path with obstacle avoidance, we need another function. Add new function. Name is adjust path to default spline. And input is original path. Vector array. For each loop, and we set location at local variable is location the and local adjusted path array. Closest line location. This is single, and point facing spline. This is Boolean. Compile. Next, we set this location. This index equal to 0. Create a branch. Get local adjusted path. Add. When it's true, we add with this location. And we get location. Break this. We use only z value. Make vector. Make this z. Get default spline. Get spline. Find location closest to world location. And change to world coordinate. Use this array element location. Break. connect X and to X, Y to Y. Next, we set closest spline location when it falls, and set point facing spline to fall. Call multi speed trace by channel. Get location on our spline, and the add location is closest spline location, and get grid gap. To float and to radius. On hit, we call for each loop this return value, we add a branch. If it's true, we add another branch. This array element we break its result and get impact point. We need to find the direction alignment check. So get location, break this vector, get unit direction with this from this location to break vector, and we make vector this X to X. We can collapse node direction alignment check, and this is the location. Dot product, get location, get closest line point, line location, get unit direction to this closest line location, connect to dot product, a cos degree, check if it's less than 90. Return this output, and this is the impact point, and connect to this branch. If it's true, we call that point facing spline is true, and when this loop is complete, we create a branch. This hit, get point facing line, create a branch. When this true, get local adjusted path, add with location. Copy this. If it falls, we get closest spline location. If this falls, we add this closest spline location to the array. And when all this loop complete, we return get local adjusted path. Name this to adjusted path file and go to event graph, define path, call this function adjust path to default spline. We want to move this spline to the default spline. Use this as original path, and this is the result adjusted path. And we continue adjust this away from obstacle and midpoint at midpoint and so on. We can open this debug for duration, play, see. Now our spline connect near this default spline for the avoiding obstacle spline. It is better. When it's overlap, this pair overlap, we don't adjust this spline. Close this, go to event graph, and this begin play, we collapse this function. Right click, collapse to function. Name this to initialize, we call AI. And we can move this down. Go to generate path spline. And this, we get path location next to this spawn new spline. And then we collapse this, collapse function. Name this to found avoiding obstacle spline. And here we collapse this to function. Name is found default spline. And it's look cleaner. Go to check target arrival. This function check target arrival. And we will adjust this logic a little bit. So we can delete this. get spline actor, get spline, then we get number of spline points, subtract it with 1, 1, and we get location at spline point. This is the location world coordinate. Get vehicle actor, get actor location and the distance. Less than. Get grid gap, multiply with 3. Let this to this float. Check this. Next is call is final target near last spline point and create a branch. If it falls, we continue this. And this one we check get spline actor not equal to default spline. And create a branch. If this is true, and we delete this avoiding obstacle. For this, find is final target near last spline point. You can adjust this logic. Delete this. Get spline actor. Get spline. And check this actor is valid. If it is valid, we return. And if it is not valid, we return this. Value is false. And this spline get location at spline point. World coordinate space. Get number of spline point next to this point index. Get final target location. Create a distance from this final target location to this spline point location. Check if less than grid gap, multiply, we divide it by 2 to float. call and boolean. Get spline actor place equal to default spline and connect to this end. We return. This we check current spline actor is avoiding obstacle spline. And go back to this. Go to event graph and go to reset pathfinding. And we check is target, final target near last line point. Check if it fall. And we don't need to reset this default spline because inside this we have destroy actor of this spline actor. So we don't need this. Close all this function. Go to can perform turn maneuver. Can perform tie K turn. We don't use this grid gap because our vehicle, some vehicle is have really big size, so we get bug collision instead. Get bug extend and split this. We use X value, copy, and this bug extend X to event graph. Go to this found avoiding obstacle spline. Before we spawn, we need to destroy the spline. Get spline actor. Check if it's not equal to default spline. Get default spline. Call and boolean. Spline actor is valid. And create a branch. If it is true, we destroy spline actor. And connect this false. If it is false, we spawn new spline. Next, we improve another logic. Call the function find next spline location. Before we use this next full spline index, so we can delete this. We use the distance instead. Get location at distance along spline. And this is world space. this spline, we get distance along spline at location to this actor location well, then we add this distance with grid gap multiplied by 4 into this and use this distance and we return this location out and this go to target location. We add another variable is new target location. Set this to true. And another one is new target location, set it to false. Go to spawn default spline. At the end of this, we reset default spline. So check this new target location or Boolean. Get spline actor is valid. Not Boolean. Create a branch. And we reset this default spline. We can copy this. When it falls, we set avoiding obstacle fall and highest input key is 0. So we don't destroy this spline actor. Compile, close this. Now we have improved some of the logic. We can check it if it is working properly. Go to vehicle AI component. Add another function. Name is spawn new path. Add this new spline point and old spline point. Now create another sequence. Create another variable. Debug found spline. If this true, we get new spline points for each loop. Draw debug sphere. This location. Radius is 60. Change this color to pink. Duration is 0.5. Thickness is 5. Get all line points. Get length. Not equal to 0. If this is true, we create another sequence. And move this up here. Get all line points. Length to float. Multiply this with 0.25. Truncate to integer. And local variable is 25%. All spline. This is integer. Set to this. And this length. Get new spline points. Zero point 0.75. Duplicate this. 25% new spline. And set to this variable. Get path overlap. Get a branch. And set should spawn. Add local should spawn. Boolean. Should spawn true. And we return. Return this should spawn. This name is spawn. And this sequence. If this false, we return. And set spawn to true. And we get 25% of all spline. For loop. Get all line points. Last index. Next to this last index. When we complete, we return this should spawn. And get all spline points. get reference of this index and set all spline point at local all spline point vector. Now set this at 25% of new spline or for loop. This is the first index and get new spline points. Last index get new spline points. Get this reference, calculate the distance from this old spline point. Less than or equal to grid gap. We do this because we want to check if the new spline is better than the old spline before we decide to spawn the new spline or not. Create a branch. If this is true, we set should spawn to false and return false. Then we create another loop. When this complete, from 0 to 25% of new spline. This new spline point, we get index and get the distance with the old spline. Less or equal to grid gap. Create a branch. If this true, we set should spawn to true. And return spawn to true. Go to event graph. Before we found this avoiding obstacle spline, we call this function should spawn new path. And get path location. So add another variable is real path location. Set it to array. Create a branch. If it's true, we spawn. And on this function, go to target location. We clear this previous path location. Clear. this calculate target speed from curvature. This reset pathfinding set to 0.5 and we clear this previous path location. Clear and check target arrival. We clear this. When we arrive at the target, and copy this to reset spline immediately. After we analyze and map obstacles, we clear this. And we found avoiding obstacle spline. This we set previous path location. Get path location. Set to previous path location. And we can debug this, debug spawn line, compile, set it to true. Now we can go to city sample vehicle map and let's play this. Use this vehicle. That is target location. You can see this is the new location that we draw the debug. That is to fall. Now close all of these functions and go to initialize vehicle AI. And we can rename this to initialize vehicle mode. Initialize vehicle variable to initialize vehicle mode. And move this down. And we get all actor of class with tag. Get all actor of class with tag. This class is actor and this tag is floor. Add another variable is floor actors. Actor. Pick reference and set this. Get length wall to 0. If this true, you need to print string. Let's set this to red. Don't forget to assign the floor tag to the landscape or ground. So in this floor, if we search for tag, we have this floor tag, and we will ignore this collision for the speed trace and line trace for our obstacle. Search for speed trace grid and get floor actor. Copy this actor to ignore. Line trace obstacle forward. Actor to ignore. Line trace obstacle right. This is to ignore. To speed trace pattern. Adjust and away from obstacle. Add this to ignore. Reset Spline immediately. We ignore this flaw. Road actor. Ignore this. Adjust path to default spline. And we ignore this multi-speed trace by channel. And perform high K turn. Ignore this. Check overlap with object. Let's ignore. Compile and we can close all this function. So now this flaw we don't need to change collision. Sometimes if we forget to change this collision, it won't work. So we need to ignore this flaw. Now we change this to block all. Let's play test. And it is working. We need to remove some of the vehicle game mode because we don't need it anymore. So go to initialize vehicle game mode. We can delete all of this. Here we unprocess the player controller and spawn default controller, and then initialize move to target, and we set block collision. File and save. We can go to graphic and e-vehicle mode and remove this mode. Follow spline loop. Only move to target and follow player. Player process, delete this and save. Go to event graph and this vehicle mode. We delete this. Only place follow player. And this reset pathfinding, we can set it to 0.5. Let's play. This is the end of our tutorial. In the next tutorial, we will prepare our project to move to one plugin so we can easily add to other project. If you like this tutorial, please hit like and please subscribe to my YouTube channel. Thank you very much for my patrons member who are supporting me. Your support make this tutorial possible. Thank you very much for watching. See you in the future tutorial.